saya akan explain. Okay, untuk hari ini saya akan explain macam mana untuk menggunakan generic cubic equation of state lah. So the informations and the equation or the parameters that you have to use is similar as table 3.1 lah. Itu awak kena ingat. Apa lagi? Kemudian dekat sini we will divide it into two actually, for liquid phase and also vapor phase. Okay, dan you perlukan information sama ada you nak gunakan whether Radicon, okay, soft Radicon and also Penrobinson lah. Okay, tu yang awak kena ingat. Faham So untuk hari ini saya akan explain tentang cubic equation of state lah. So generic cubic equation of state. So untuk generic cubic equation of state, awak kena consider first adalah dia punya phase dulu. Okay, generic equation. Itu yang awak kena ingat. Sebab calculation is based on the iterations as well as with the equation of PV equal to ZRT. Okay, the main thing is you have to determine the compressibility factor. Okay, so once you determine the compressibility factor, okay, PV equal to ZRT namanya. Okay, once you determine Z, so you substitute into this equation and then you can calculate a PV or T. Okay, that's the thermodynamic properties lah. So if you look at here that for example for the solution of the volume, right? For the solution of the volume to calculate volume lah. So you need a trial and error as well as the iteration lah. Okay. So if you have a software like macam mathematical software kan, so you can use that one lah, but not for the exam. Okay. As well as you kena iterate until it converge. Okay, you kena ingat yang tu. So kita tengok vapor. Okay. Vapor satu and then kita akan tengok liquid lah. So kalau macam mana awak nak determine the phase, you have to refer the table that I already explained, okay, in the previous class if you still remember. Okay, what happen if the temperature is more than Tc? Okay, what phase is that? Okay, we can know that if T more than Tc, it is vapor phase or gas lah. Okay, if temperature below than Tc, okay, and pressure is more than Tc, is going to be liquid. Okay, or you can determine by using PT diagram. Okay, this one lah. And this one is PT diagram. So you can predict from this one. Okay. And then for the generic cubic equations, the equation that the important equation that you can use actually is this one. Okay, this is for Z lah. Okay, how to determine Z, and to calculate beta and also Q. Okay, so you have to refer to this equation. Okay, this one. Ini boleh dapat dalam buku lah. Okay, B is equal to ohm PR divided by T lah, and Q is equal to this one. Okay, alpha TR divided by this one. Okay, TR. Okay, so to calculate TR, it should be equal to T divided by TC lah. TR is going to be P divided by P TC. Okay, so you have to remember that. Okay, just using this one, the one that I box here. Okay, and then beta and Q you substitute into this equation. This is only for vapor or gas. Okay, that's why you have to determine the phase first. Okay, how to start your iteration process to determine that for this Z. So meaning that this one, if you want to do iteration Z I plus 1 equal to this one is going to be Zi, and this one Zi, this one also Zi. Okay, we start with the Z equal to 1 lah. Okay, that one is for the gas. For the liquid, the assumption for the Z value is going to be different. It's not equal to 1. Okay, it's going to be equal to B. Okay, Okay, so the value of epsilons, okay, and also sigma actually is depending on whether you want to use a Radix-Wong, okay, soft Radix-Wong, uh, pair Robinson or Van der Waals. Okay, itu yang kena ingat. So once you determine Z, okay, here once you determine Z, you calculate the new Z lah, and then you return again to this calculation and you calculate until it converge until you get the final Z. And then once you get the final Z, you substitute into equation PV equal to Z ZRT if you want to calculate the volume. Okay, so that is for the vapor. For the liquid, if you look at here, is almost similar equation. Okay, but I think the difference is only on the this this one, okay, and also this equation lah. I think it's all is it's different. Only the parameters is similar. How to determine beta, epsilon, okay, sigma, and also q lah. So for the assumption, okay, z initial z is equal to b, not b. It should be beta. Okay, it should be beta. Okay, if you look at here, is start with the beta lah. The previous one you should start with 1. I like you to use this equation, vapor and liquid lah, rather than the previous one by the polynomial form. Okay, so this is but from the polynomial you can directly calculate the volumes. Okay, itu tak ada masalah. Yang ni you have to calculate the z first and then you have to substitute that the final z into the PV equal to z ZRT. Okay. Okay. So let's see this example. Okay, if you look at here, that given the vapor pressure of N-butane, right, at 350 uh, Kelvin and 9.4573 bar. Okay, find the volume of saturated vapor and also saturated liquid and butane at the condition as given by the Radix-Wong. Okay, A is equal to saturated vapor and B is a saturated liquid. This is already stated that you have to calculate first for vapor and another one is for liquid. If not stated, at this condition you have to find, okay, whether this condition your component is in liquid or in vapor. Okay, you kena ingat lah dekat situ. Faham eh? Okay, can you calculate this one? Okay, so if you look at here, sekejap eh. Sekejap eh. Okay, look at this one first. Can you calculate by using the equation of vapor and also liquid? I will do sekejap eh. Jambot. Okay. SETK 2253 2021 2022. Okay, so I'll give you the link for the Jamboard, right? Okay, so let's we do together. I'm not sure if using the Jamboard. Ada ni tak? Rasa ada tak? Okay, boleh nampak eh? Okay, so kalau if you look at here, okay, alamak. Okay. So initially get the information. Okay. Maksudnya dia punya pressure, dia punya temperature lah. Faham eh? So apa yang kita perlu buat adalah okay. Okay. So if you look at here that given the vapor pressure of N-butane and 350 Kelvin in 300 50 Kelvin is 9.4573 bar. Find the volume saturated vapor and saturated liquid and butane at this condition as given by Redick Wong. Okay. So what you have to do is of course the N is equal to alamak saya tak ada ni. Okay, N is equal to N the component is N butane. Okay, N butane. Okay, and then the temperature is 350 Kelvin. Okay, and then the pressure is 9.4573 lah. Bah. Okay. What you have to do is you determine the TC and PC. How to determine this TC and PC? Hmm? How can we determine TC and PC? Table B1, yes, table B1. So please determine TC and PC. What is the value? Okay, once you determine TC and PC, you have to calculate P, R, and also PR. Okay, so please calculate PR and PR. Okay, since it's stated that you have to use the Redick-Kwong equation, isn't it? So please refer to the table 3.1. What is the value of alpha TR? Okay, if you don't have any textbooks, you can just Google. Okay, you can find it from the website or from the Google image. Just write the what we call it as a what is it? Thermodynamic properties saya rasa. Apa? What is the title in the textbook? Wait, I will find. Okay. Parameters for the equation of state. Okay, that one. Parameters for equation of state. So you just Google and you can find that value. Okay. So the value of sigma. Please give me the value. Okay. I think you can write your answer and post it in the Jamboard. Okay. I already give the link, right? Epsilon. What else? This one. And also ZC. Boleh dapat Okay. So once you determine these parameters for the Redick-Kwong equations, please calculate Q and also beta. So how to calculate Q and beta? Okay. Please refer to the beta equation and Q equations. Okay. Once you determine this one, the equation, if you refer to my slide, right? Q is equal to PR divided by beta. And beta is equal to, I'll just bring it down. Go through. PR. TR. Okay, so please determine this one. Give me the value of Q and beta. Okay, so once you determine all this value, okay, please use a vapor phase because it's stated for A is for saturated vapor. Okay, so 1 plus beta minus Q beta kan, Z minus beta divided by Z plus beta. Okay, this one is for saturated vapor. So how to get the Z initial gas? Make it Z not equal to 1, meaning that you have to make it this equation Zi plus 1. Zi. Okay, if Z naught is equal to 1, equal to 0, meaning that this one you have to do Z1. Okay, and then Z2, Z3, Z1, Z2, Z3, and so on. Okay, could you please determine the value of TR, PR? Okay, what is the value of TC, PC, TR, PR? Okay, can you give me? I can give you 5 minutes. Find TC, PC, TR, PR, alpha, TR, sigma, epsilon, and I don't know what we call it, the symbol. Okay, PC 13, yeah, PC 0. 0.8232. Okay. So you will get TC is equal to 425.1 and then PC 37.96. Okay. And then TR 0.8233 and PR is equal to 0.24991. Okay, this one you just determine from the tables. Okay, how about Q and beta?
Say again, how to find the the variables for the middle one?
Which one? This one?
Yes, it is. Just now I Google search lah, I didn't get.
You have to refer to the table 3.1 for your main textbook.
Table 3.1.
Your main textbook.
Alright.
Textbook. Okay, or if you Google it, parameter assignment for equation of state. I'm not sure from the Google. I think it's there. They have. Okay, once you write that parameter assignment for the equation of states, I think it can be. I think it's gonna be appear. Ada tak?
Skip eh.
Okay.
Ada.
Okay. Okay. Dah dapat So once you determine Q and beta, okay, please substitute into these equations. Okay, for vapor, and do the iteration. Please start do iteration. Okay. Please start Z naught is equal to 1. Please do the iteration. What is the value of Q and beta? Mana? Yeah. Oh ya lah. Akhir lagi nak ngaji. Nampak tak tu? Pukul 6. Pergi terus lah. Pergi terus je lah. Okay. Okay. Online lah, ngaji online. Buat. Okay, what's the value for what's the value for Q and beta? Okay, the value the equation for Q, okay. The equation for Q it should be yang ni. Yang ni lah. Ini alpha TR, alpha TR this one and this one TR. Okay. Not TR divided by PR. Okay, look at this one first. This one alpha TR or ATR. This one. So if you look at here, from table 3.1, okay, this one is alpha TR. I use A lah here. So for the Kwang, it should be TR negative half, power of negative half. 1, 0, 0.08994, 8664, 0.42, 1 divided by 3 as see I think we not use it this parameter. Okay. So just substitute alpha TR with TR and you have to find the TR, the value of TR. Dah hilang lah. Okay, once you determine Q, I think you have to do, I'm not sure how many iterations, 6 or 5. I'm not going to teach you how to do iteration, okay? So you have to find out lah. Because you, I think all of you already taking the, what is it? Mathematics, okay? mathematics 1 and mathematics 2. So Q and beta. So Z I plus 1 equal to, what is the equation? 1 plus beta minus Q beta Z minus beta Zi lah, divided by Z I Z I plus beta. Okay? Okay, you start I with 0. Okay, then I with 1. I equal to 2 and so on. Okay? So you substitute into this equation, this value, and so on lah. So please find the final Z. What is the value for the final Z? TCT, what? There's someone who write in the Jamboard. TC is equal to, okay, TC. So what is the answer?
Doctor, is
Beta, yes.
is Q equal to 5.43?
You can write, okay, you can write in the chat box, you can see here. Okay, 5.43, or you can put in the Jamboard. Okay, Q. What is the value of Q? I don't know what is the value of Q. What is the value of Q? Yeah. So the value of Q is equal to John Ting, I think is wrong, John Ting. You have to recalculate, I think. Okay. And also, yeah, Fong Chai Woon. Okay. 6.6048. Okay. And beta 0.0262. Okay, that's good. Who's writing in the who post it in the Jamboard? So that is the value. Okay, that's good. Okay, so you can start to do the iteration. So please do quickly. If not, we are not moving to the other examples or other tutorials. Okay, once you know how to solve this example 3A, I think it's no problem for the uh, what is it, B1 for the saturated liquid. Since it's a similar step, the difference is only the equation that you use for the saturated liquid, which you have to replace it with the liquid one lah. Okay, rather than you use the vapor. If you use the vapor, your answer is gonna be not accurate. Okay, faham eh? Okay, so what is the answer for the Z? Okay, once you determine the Z Z final. Okay, Z final. Give me the value. And once you determine ZF, okay, PV equal to ZFRT lah. So you can calculate the volume. Just substitute all the values of the pressure, compressibility factor that you determine from the iteration process. Okay, iteration step. R that's constant, and also the temperature. This is you substitute here. Okay, you can get the value of V. Okay, so if you want to do the comparison from the experimental, because this one you calculated, right? The experimental value is 2482 lah. This is the value of V from the experimental. Meaning that is the real volume lah. Okay, centimeter cubic centimeter per mole. This one is from the experimental. How about yours from the calculated one? Okay, so give me the answer.
Sorry, Tata. Is the if I equal to 0, right? So is Z1 equal to, and then forming the formula, and the ZI is also
Z0.
is the
Assumption
variation
Z0 lah.
with the Z1?
No, this one ZI plus 1.
Yes, yes. So Z
This
initial,
one is 0 lah. 0. This one 0 lah.
yeah.
So,
How to get it?
how to get?
PV equal to ZT.
No. You
No.
have to determine Z first. Initial Z, what is the initial Z? What is your assumption? Z is equal to what?
Oh,
Just
Z equal to 1.
Z equal to 1, right? So you
Yeah.
substitute first this
Oh,
one Z equal to 1, this one Z
oh
equal to
yeah, yeah.
1, Z equal to. So
Oh,
this one is Z not equal to
1.
1. And then you can
Okay.
get Z1. After that,
Alright,
Z1 is you have to substitute here lah, Z1. Okay, Z2, Z2.
alright.
This is the iteration. 435. Almost. Okay, what is the answer? This should be converged. Okay. What is the answer? 1168. It should be close with this one. You see? What is the unit? I don't know what is it the answer is correct or not. And the unit, there is no unit. Is it in kilojoule per mole or meter cubic per mole? Okay. It should be close with this answer. This is from the experimental. Okay. So it's gonna be 2000 something. Alright.
Total is 2556 acceptable.
Yeah.
All
So
right.
that's okay. Okay. So for the saturated liquid, I think this is not. I think it's the you can solve it for the saturated liquid lah. Just change it to the equation of this equation. Which one ah? Where's the liquid? Ah, this one. Okay, just change the equation with this one. Liquid. If you look at here, this is a polyliquid liquid, right? Okay. This the similar step. Okay, you do the iteration and then you substitute the value of beta. But for this one, z naught is equal to beta. Okay, not equal to 1. You have to remember, z equal to beta. Okay, faham eh? Okay, so let's see this one. Okay, example 4. Since it's not stated whether the condition, the ethylene is in the liquid or gas, okay, could you please determine whether ethylene in gas phase or liquid phase? Okay, Z 0.28. Okay, who answered that Z equal to 0.8305 is Z equal to 0.35. Yes, that is correct. And V255 should have the how to say the unit. Okay, meter cubic per mole. No unit is wrong, so you get 0 mark. Okay, paham eh? So could you identify the phase of this ethylene, whether liquid or vapor? Anyone? How to determine this one? Any suggestion? Guess. How do you know it gas, Akmal? T more than TC, and then T more than TC, and then how about pressure? Okay, so if you look at here, okay, roughly, okay, just roughly that I sketch, okay, so T more than TC lah, okay, ikut table dia just stop gitu. Okay, so if you look at here from T and TC value, right? Okay, since just sketch lah. So for you, I think so you can see more clearly. Right. Okay, so this is a critical point. This critical point. So critical point is what is the critical point? TC 282, right? Two. This one is pressure. Pressure is 50 bar. 4 bar. And temperature is 282 Kelvin. Okay, so since it's stated that 25 bar and 12 bar, 25 degrees C and 12 bar, this is a 50 bar right here. It's a little bit uh, 50, 25 lebih kurang sini lah and then 282 Kelvin and then 25. Kan? 25 Okay. Okay, so here lah. 25 degrees C is equal to 282 298. No. 298 here. Okay. So it's more here. So here lah. 298. Okay, 298 Kelvin. Okay, and lower pressure. So meaning that P below than PC, T more than TC. Okay, so in this area. So definitely because it's more than the critical points, yes, T more than TC. Okay, so guys, gas phase. Okay. So similarly like a previous example, okay, example 3, we have around 7. This one I just explained. For the next class, please solve it. Okay, I hope that you can solve it. Okay, you can solve it. 282. Okay. You can solve it and give me the answer. Okay, for all this by using these three parameters. Okay, for the cubic equation of state. Okay, so using since it's gas, so you have to using the which equations you have to refer to vapor. Okay, this one. Okay, and then about the parameters, please refer to table 3.1. This one. Okay, so if you look at here that it's stated you have to use a Radcliffe-Quong and also Penn-Robinson. So you have to calculate all the answer. Which one is more accurate? Okay. Any questions about the method of vapor and liquid? Okay.
Yeah,
Yeah.
sorry for asking the same question again. To confirm.
Uh-huh.
The iteration,
Uh-huh.
we need to stop until the percentage error is around 5%, right?
Not really. The more converge is much better lah. Okay, but
Or
if around your 5% or 3%, I think the below than 3% is okay. Okay, not really. I think the value is not really difference lah. Okay, not a large difference. Make it a more close. Okay, if you feel is from the previous value and the final value is still have a large differences, so you have to recalculate. I mean, do the iterations once again. Okay, just to confirm. Okay. Okay, but generally not really for this one. I don't think it's until 20 iterations. Maybe
just
even 5 or 6 or 7. That's all. Okay,
oh,
you can get the actual value or the final value. Okay.
all right.
Okay.
Doctor,
Yeah.
for the iteration, right, we need to show the working on how many iterations.
I think you have to because you just calculate by using what is it your scientific calculator, right?
Yes.
I think the value of Z, only the value of Z. The initial, I think for the initial you have to write, but the rest starting from Z1, Z2, you just give the value of Z1, Z2, and so on until the final Z. Okay.
Okay, thank you, doctor.
Okay. Okay. Because now you use a scientific calculator, so it's much easier, right? Rather than you, yeah, during my generations, I have to calculate, okay, write down all the iteration process. But now I think it's much easier. Okay. So if no more questions, that's all for today, and thank you very much. I will upload again the video later in the YouTube, and not YouTube. Yeah, I think it's I'm gonna upload in the YouTube and give you the links later.